So let me introduce myself. First of all, my name is Martin Broomhead and I'm the General Manager for D-Fend Solutions. First, and also let me just say thank you very much to the Defence IQ team. It's been an incredible event and one organised under very difficult situations. Today I'm going to be talking to you about taking control of the drone threat in sensitive environments. So just moving on the slides. So I just want to say a little bit about D-Fend Solutions, and then I'm going to go into a much more sort of generic type presentation talking about the type of capabilities needed in urban environments. We are a leading provider of counter-drone solutions in complex, sensitive and challenging environments. We've been running since 2017 and we've already amassed a great deal of experience, including 18 months of co-development and competition in the US, where we were eventually selected by the US DoD as the RS/cyber solution of choice. We are already working with multiple agencies within the US, including the FBI, the Department of Justice, Department of Defense, the Army, the Navy, and we've delivered over 100 units to them to date this year. Coupled with that, our mobile solution, which can quickly be transferred from a static into the back of a standard family vehicle, that is already being deployed by the security services in the US and is currently protecting some very important politicians. Outside of the US, we have had some considerable success in Asia, in Australia, and in Europe as well. As I said, over that period, we have amassed an impressive list of customers and partners that we work with on a daily basis, and some of those are represented here on that slide. Right, let's move on. So, the agenda today, I'm going to talk about the environment and the threat, the challenges and considerations of traditional counter-UAS technologies, and the required capabilities for the safe and effective operation of counter-UAS solutions. In this slide, we have three hostile drone incident examples. It's a few examples of sensitive environments. We have the mega events, such as stadium, sporting or concert events, and a large gathering of festivals or indeed even protests. Critical infrastructure, such as nuclear power sites or oil refineries, and government facilities, including military bases. There are also prisons, airports, military combat zones, and urban density. So here's a slide with three hostile drone incident examples. The first, during a football match between Serbia and Albania. As a politically motivated act, a drone carrying a banner bearing the Albanian flag was flown into the stadium, causing mass disruption and rioting, leading to the match having to be abandoned. The second, in 2018, a Greenpeace activist flew a Superman drone into the side of a French nuclear restricted facility, done ironically to highlight the vulnerability of this type of facility to terrorist attack. The third, in 2015, a drone is landed on the roof of the Japanese PM's residence. The drone was said to be carrying a payload of radioactive sand from the closed Fukushima nuclear power plant. This was, again, a politically motivated attack in protest against the planned recommissioning of Japanese nuclear reactors. In this next slide, we just briefly look at as many people have today, look at the London Gatwick, 3 days of drone disruption in December 18, more than 1,000 flights diverted or cancelled, 140,000 passengers affected, with a cost of the airlines estimated to be in the tens of millions of pounds. The police operation and subsequent investigation is believed to have cost a further £1 million, and there was no subsequent arrests. In Madrid, earlier this year, an unconfirmed drone sighting compelled the airport authority to hold all departing aircraft and divert all inbound traffic. The incident was resolved within 3 hours, but not before causing considerable disruption with a substantial cost impact to the airlines. So continuing with aviation and the high risk factor, there are many well-documented examples of near misses between aircraft and drones. Indeed, the internet is littered with video examples of reckless, some might say feckless, drone operations. The potential for catastrophic damage following a drone strike is clearly illustrated in this well-known video footage. The secondary risk of fire from the damage of lithium battery cannot be discounted either. Another point actually well made yesterday and worthy of repeating again is that this type of incident poses a significant threat to all types of aviation, not just large airliners flying in and out of international airports. So just to talk about the type of drones that are used, the type of drone used in the previously described incidents were all commercial grade and easily purchased via the internet as either a complete package or as component parts and assembled by a reasonably competent individual. They're low cost of entry, they're easy to buy, and they're even easier to fly straight from the box. So the type of drones, as discussed in an earlier presentations, there are many types of drones, some of which may pose little or no threat to our operations. It is therefore important for a counter-UAS solution to categorize and prioritize the threat posed by each classification of drone and deal with them accordingly. When we look at traditional counter-drone solution challenges, such as in the detection, we look at radar, optical, DF, and acoustic. If you look over on the left of ARC in rural and open-air environments, then of course they perform a lot. They perform reasonably well, but as you move into the urban, densely packed environments, they tend to reduce in efficiency. And are predators to things like false objects, false positives, and having no clear line of sight. On the mitigation side, the radio-controlled jamming and kinetic solutions are again okay in the rural and open-air environments, but less able to deal with urban environments because of the unacceptable signal disruption and potential for collateral damage. It's generally recognized that the intersection of drones, two-way communications, is an effective way of detecting a drone in an urban environment. And taking control of the drone and diverting it to land at a pre-planned safe location is an equally effective way of mitigating the threat and controlling the whole incident life cycle. In by far the majority of cases, suspect drones in or around sensitive urban environments are being flown by irresponsible or naive hobbyists rather than terrorist or hostile actors. Therefore, a response proportional to the threat is important, especially in dense urban environments where the use of perhaps things like an adapted shotgun or a high-powered jammer, for instance, would not be an acceptable mitigation option. Some of the critical capabilities that are required is scalable autonomy. So it is desirable that this system should be able to work autonomously, but it also that at times you may need to put a human in the loop to, for instance, action the mitigation part of the system, rather than letting it do that on its own, depending on the situation, of course. You need to be able to full management of the incident life cycle, and we'll talk a little bit more about that later. You want to be able to take over communication link of the rogue drones using a low power signal. You need to land drones autonomously and safely in a pre-designated safe landing point. And you need to be able to control multiple drone scenarios, and by that I mean swarm scenarios. Dense environmental requirements, so the system must be non-jamming, non-kinetic, and not reliant on line of sight. It must also be friend or foe selective. So I talked earlier, or mentioned earlier, what we call the incident life cycle. The urban counter-UAS solution should ideally passively detect, track, and identify all rogue drones of interest, whilst also pointing to the location of their operators. If time permits, it may be appropriate at this point to rapidly pass that information to the appropriate law enforcement agency and allow them to deal with it. I think this, just to pause there a moment, is an ideal solution. And just going back to the earlier presentation, I think this is about the management of rule of law, and it's up to the law enforcement agencies to deal with individuals where possible. So that as soon as we can put it back into their hands, the better. Where there is a need to deny access to a restricted urban area, then it is most likely you'll require a scalable, non-kinetic mitigation approach rather than a high inertia kinetic mitigation action. This is only really possible when you are able to control the full incident life cycle. Detect and alert and urban counter-UAS systems should passively detect drones within a defined radius, whilst not requiring clear line of sight. Locate and track. The system should be able to present real-time location and tracking information. Identify. The system should mark detected drones with unique communication identifiers, create a unique ID, type classification that also identifies it as friend or foe. Now, data extraction, it needs to identify with GPS actually the drone's location, its takeoff position, and then point to the drone's pilot's likely location. Assuming it's necessary and where legal to do so, you then might need to go into mitigation action. So in the first line of defense might be that the system should prevent a rogue drone from entering a restricted area by, for instance, disconnecting the control signal of the drone's operator and triggering the drone's return to home protocols. The drone operator can only regain control by switching both the drone and the radio control unit off and on again. And by now, hopefully, the police are on the way to deal with the situation. The next line of defense in this system is the take control of land. It transmits a unique low power control signal to set a new flight plan for the safe landing of the drone in a predefined point via a safe route. The D-Fend system does that, lands it within 1 meter of the designated point. So here's a great example. Airports are a great example of the need for counter-UAS solutions to have multiple use capabilities, able to manage complex and sensitive environments. To be effective, the system should be capable of accurately mapping and protecting an airfield perimeter, providing 360-degree coverage of large expanses of real estate, and providing focused runway protection, and capable of projecting coverage to include the approach and departure flight path. So when we talk about flexibility form factor, you really need to ensure that your counter-UAS system is adaptable to multiple use scenarios and can be rapidly, for instance, transferred from a static to a mobile solution and then operated whilst mobile. So the importance of ongoing access to critical domain expertise. So this is I think, plays quite well to some earlier presentations where they talked about choosing a partner, not a vendor. That partner needs to have advanced skill sets, competencies, and demonstrable experience relevant to the ongoing UAS threat and the counter UAS response. Choose a solution that meets your requirement. Be very clear about this. Make sure it aligns with your strategy, and make sure that the technology is deployable across multiple domains. As far as ongoing updates, you need to future-proof the control protocol. You need to make sure that the protocols that are controllable are fit with your threat and intention to use the device, and you must keep pace with future UAS development. That is a future-proofing. Whatever solution that you buy is an absolutely critical capability that you must ensure your partner has. And just by the way, D-Fend are the largest company that have a 100% commitment and focus on ensuring that we have a very robust and mature threat library. So, in summary, in a sensitive urban environment, I'd like to re-emphasize the importance of controlling the whole life cycle of a drone incident with a system that passively and autonomously monitors drone traffic and is capable of providing timely information to law enforcement agencies, but when required is also capable of mitigating the threat using proportional mitigation action. So with that, I'll say thank you and hand over for questions.
Martin, thank you. Thank you for your insights and for your time today and sharing your presentation. We'll kick off with a question from the audience, and it's from Jan Link. How do you make sure that your system is not misused to take over police drones? So how do you make sure that your system is not misused to take over police drones?
That's a very interesting question. Yes, I mean, I would I'd probably need to take that one away. But there are some security protocols around the system that prevent it from being infiltrated in that way, and the unique identifiers placed on drones would also prevent that from happening.
Okay, lovely, thank you. A further question here from Mayor Benchire, who asks, will your system be able to detect and mitigate drones operating by cellular communication? So will your system be able to detect and mitigate drones operating by cellular communication?
Again, another interesting question. And so what we do when we talk about mitigating threats, it's about proportional threat reaction. So, what is out there, what is absolutely viable at the moment, and what are you really going to need to defend against? 5G is an interesting one, and we're tracking that closely. Although we don't currently mitigate drones flown by 5G, as that technology and capability matures, and where we see customers needing that as a threat mitigation, then that is certainly something that we would react to accordingly.
Okay, thank you. Further question here. So you talked about takeover. What are the most important drones for which takeover should be addressed in a solution? So what are the most important drones for which takeover should be addressed in a solution?
Again, this is about, and I go back to my previous comment about proportional threat mitigation. On the, I suppose on the left of ARC, or the right of ARC, which way you look at it, you have the small Wi-Fi drones. Now, I'm not dismissing that they're a menace and that they need to be. So, we do mitigate Wi-Fi drones. But also, there are much more sophisticated, capable drones capable of carrying 2 kilogram plus payloads. Those both because of their size and their capability and the potential threat, do pose a much larger threat. So it's very important, I think, and it's very much the case with us, that it covers all of the DJI drones, that it covers Lightbridge and it covers OcuSync, and in particular OcuSync 2.0, which is the latest version.
Okay, thank you. And the final question, do you support the latest OcuSync and Lightbridge protocols? So do you support the latest OcuSync and Lightbridge protocols?
And I refer to my previous question, and the answer is yes.
Okay, thank you. Martin, it's been brilliant to have you with us today. Thank you very much for your time and your insights. All very much appreciated. We will now move on to the next session, and I am absolutely delighted to introduce Sergio Bermejo, who is the specialist in counter-unmanned aerial systems at the Special Tactics Team at Europol.